make sure you do that, please. Today we're going to go over areas of trapezoids, rhombi, and kites. Okay, so previously we went over area of parallelograms and area of triangles. Now we have trapezoids and rhombi and kites. So if you forgot what a trapezoid is, it is a quadrilateral. Okay, again, that's a four-sided figure with two parallel sides. Okay, so those parallel sides in your trapezoid are going to be considered the bases. Okay, so those bases are parallel to each other. And the height of your trapezoid, again, is that perpendicular distance between your bases. Okay, so you still need that height and you need those two bases. So, again, the height is the perpendicular distance between the two bases. I'll highlight that here so you can see it a little bit better. Okay, so the height, the perpendicular distance. All right, so the area of the parallelogram is the product of the height h and the sum of two bases b1 and b2. The area of one trapezoid is 1/2 the area of the parallelogram. Okay, so we do need the bases of a trapezoid in order to find the area. So our area formula for a trapezoid is the height, h, multiplied by one of the bases plus the other base, then divided by 2. Okay, so you're going to take the height, multiply it by your bases added together, then divide that by 2. So again, your bases are those parallel sides right here. Okay, not the two lines that would intersect if you would extend them. Okay, it has to be those parallel sides for your bases. So we are going to go over a couple examples here. So number 1, the purse at the left is in the shape of a trapezoid. How much material is needed to make the side of the purse that is showing? Okay, so it is in the shape of a trapezoid. We need to locate the height. Okay, so the height, again, is that perpendicular distance between your two bases.
30.
Okay, so the height will be 30. Okay, then we also need the two bases. Okay, so our first base right here would be 28. Second base would be 58. Okay, those are your parallel sides. So I'm just going to use the area formula. Plug it in. So I have h, our height, is 30, times the quantity of base sub 1 is 28, plus base sub 2 is 58, then divided by 2. Okay, so once I add this quantity together right here, I would end up with 30 times 86 divided by 2. So I just added 28 and 58 together. Okay, then I can multiply these two numbers together and then divide it by 2 to get 1,290, and this would be in centimeters squared.
Hey, calm down.
What? What? I was making sure I was right.
You're right.
Did you enter it in your calculator?
Yes, I did.
Sometimes I'm incorrect. It happens. All right, questions on number 1. All right, then I want you guys to do number 2. Do number 2.
Okay. I'm really flipping. I'm flipping marbles here.
Mm-hmm. Do number 2.
Will you show me after? No. If I do it?
Maybe.
Hello?
You can wear my sweatshirt.
What's the answer for?
Do it on your calculator.
I'm not calculating 4.
If I have an
Calculator.
calculator.
You can too. But you have to buy them.
Multiply it.
You can wear my sweatshirt.
I did it.
Good job.
2,980,000 inches squared. Bless you.
All right, so to set this up, again, you need the height. The height is this perpendicular distance between your 2 bases. That's 38. Multiplied by your 2 bases added together, so 72 and 85. Then divided by 2. Okay, and you should have gotten the area to be 2,983 inches squared. Okay, questions on number 2?
I got it right. Can you keep going? Hey, keep going.
What?
I'm gonna make my face tighter.
Why would it times it by 2? There's not 2.
Can we do the next one?
There's 1. Alright, so number 3 says, what is the area of one earring that is in the shape of an isosceles trapezoid? Now, an isosceles trapezoid means that your legs in the trapezoid are congruent.
We both 3.
So they're both 3, yep.
Would be 6.
No.
No.
Okay, so we don't have the height, okay, in this trapezoid. No, it's not. No. Your height has to be the perpendicular distance between your 2 bases. Okay, now if I draw in both of those, okay, draw in both, right? What is this space right here? How long is it? 2. Now, since this is an isosceles trapezoid, I still have 2 centimeters remaining to split between these 2 ends here. Okay, so each of those pieces will be 1 centimeter. Now, what I did was create this right triangle right here, and I have a hypotenuse of 3 and a leg of 1, and I'm able to find the height of this trapezoid then. Okay, I'm going to use the Pythagorean theorem to do that. So I would take 1 squared plus h squared is equal to 3 squared. So I have 1 plus h squared is equal to 9. Subtract 1 from both sides. I have h squared equals 8. Take the square root of both sides. So our height is going to be 2.8. About that. Okay, then for my area, I need 1 base and a second base as well. What's one of my bases? 2. What's the other one? 4. So now that I have the height and both bases, I can find the area of this trapezoid. So I need the height of 2.8 times the quantity of both bases added together, then divided by 2.
8.4.
Yes.
I just tried to write a C backwards.
Okay, and once you plug that into your calculator, you should get 8.4 centimeters squared.
Is that the easiest lesson
Okay, questions on finding the area of a trapezoid? All right, then if you go to the back, we have a rhombus and a kite. Okay, we went over rhombus and kites in chapter 6. Shh, we're quiet, please. Okay, so we went over different properties when we went over these in chapter 6. Now we're going to find the area of both. So a rhombus is a parallelogram with all 4 sides congruent. Okay, so parallelogram where all 4 of your sides are congruent to each other. So that means this shape right here would be a rhombus. Okay, all 4 of these sides are marked as congruent. Now a kite is different than a rhombus. A kite is a quadrilateral. With exactly 2 pairs of consecutive congruent sides. So again, consecutive congruent sides means that the 2 sides next to each other are congruent. So one pair would be here, the other pair would be here. So this one is a kite. Just to remind you what they look like. He's just not here today. Oh, he's not here anymore. All right, so focus. So we can find the area of a rhombus and a kite. They both have the same area formula. So that formula is 1/2 times one diagonal times the other diagonal. Okay, or you can think of it as diagonal 1 times diagonal 2 divided by 2. Okay, so multiply your 2 diagonals together, then divide by 2. So here you have a rhombus. Shh, we're quiet and paying attention. Here you have a rhombus. Now in a rhombus, again, your diagonals are perpendicular, indicating you will probably have to use the Pythagorean theorem at some point to find one of the sides. Okay? Now you also have in a rhombus, your diagonals bisect each other. Okay? So your diagonals will bisect. You guys, I need you to pay attention. So each piece is congruent to the other. In a kite, your diagonals, again, are perpendicular. Okay, so they form that 90-degree angle. And one of your diagonals does get bisected. Okay, that would be this one here. Okay, the other 2 do not. So those 2 pieces right there are not congruent like they are in a rhombus. Okay, so that's a way to tell the rhombus and the kite apart. So we are going to go through a couple problems here finding the area of a rhombus and a kite. So the first one, 3A, this one is a rhombus. Okay, so this is a rhombus because your diagonals bisect each other. Okay, I see that by these congruency markers. So if this piece of that diagonal is 6, that means this piece is also 6. If this one is 7, that means this one is 7. And I can find the entire length of that diagonal. Okay, so I just have to add those two measures together. That'd be 14 millimeters. And same thing with this diagonal here. Okay, 6 and 6 is 12 millimeters. Okay, so now that I have both my diagonals, I have D sub 1 and D sub 2. I can find the area of this rhombus by multiplying them together and dividing by 2. Okay, and you should get 84 millimeters squared. Okay, questions? All right, do 3B. Good job. 3B. All right, so 3B. Shh. Since you guys are going to start talking here right away, I'm going to go over the problem. So 3B, you are given both diagonals already. Okay, so you have one diagonal of 9 inches and a second diagonal of 16 inches. Okay, so plugging those into the area formula for a kite, multiply your two diagonals, divide by 2. And you get 72 inches squared, yes. No. No. Other questions on 3B? All right. 3C. We want to find the area of the kite shown. Now, to find the area, again, we need the diagonals. Okay, I'm given one piece of this diagonal here is 6. Okay, this piece right here is 6. This length right here is 10. This length is 17. Now, shh, we are quiet, please, and we're paying attention. Now, what I can do first to find this diagonal, okay, is use the Pythagorean theorem. Okay, again, your diagonals are perpendicular. And I know this length here is 6 and that length is 10. Okay, so I'll label this one as x. So we would have 6 squared plus x squared is equal to 10 squared using the Pythagorean theorem. Okay, 6 squared is 36 and 10 squared is 100. Subtract 36 from both sides. Take the square root. Okay, now that x value is 8. So that piece of that diagonal is 8. Now since this is a kite, and I know one of the two of my diagonals bisects, okay, meaning both pieces are congruent to each other. I know this side right here next to that 6 is what length? Given properties of a kite. If this length is 10, this length has to be 10. Okay? You have consecutive congruent sides. Okay, so if this one's 10, that one's 10, this one is 6. Since this also makes a right triangle with 6 and 10, that means this piece of this diagonal also has to be 8. Okay, so I know one of my diagonals now is what? Is 16. Now I'm still missing my second diagonal. I have a piece of it is 6 inches, but I'm missing this piece right here. Okay, how can I find that piece that I labeled y? Pythagorean theorem, right? So I have this side is 8, and this side is 17. How would I set up this Pythagorean theorem? How would you set it up?
X squared plus y
Y, whatever.
Yes. Okay, so 8 squared is 64. 17 squared is 289. Subtract 64. We get 225. Take the square root. That y value I labeled is 15. Okay, so that length right there is 15. So now I have both pieces of that diagonal. So I can add those pieces together to get that diagonal. So now since I have both diagonals, I can find the area of this kite. Okay, so multiply your two diagonals together, 16 times 21, and divide it by 2. And you should get 168 inches squared.
Bring it on.